Pristine, natural, eternal. This is how we tend to think of the planet's wild places. The picturesque Roanoke River would seem to fit those notions indeed. The river courses over 400 miles from the Blue Ridge Mountains of Virginia through North Carolina Piedmont and precious bottomland hardwood forest to Albemarle Sound at the Outer Banks, and finally, the Atlantic Ocean. The river system hosts over 300 fish and bird species and a rich variety of mammals. This includes humans, of course, who first came to these waters thousands of years ago. Yes, the Roanoke may seem postcard perfect, but postcards, like the Roanoke's opaque waters, can hide more than they reveal. The once clear river now runs thick and brown, flooding the lower river with mud. Some of this mud makes its way to the ocean. But as this extraordinary satellite image reveals, not before inundating the Sound. Still more mud is piling up along the river on the lowland or floodplain, redefining the look and function of the lower river system. What triggered this flood of mud? And how is it changing an ancient treasure forever? Between colonial times and the Great Depression, much of the forest up and down the eastern seaboard fell to the blade of an axe or saw. Farming was the backbone of the early American economy, and continuous agricultural expansion was the order of the day. Converting forest to field was a means to that end. In addition, harvesting trees was profitable.
The trees were valuable because in England, wood was scarce. Now they were in an abundance of ship's mast, timbers, that they could ship back to England as a sellable product. Plus, we find the development in the early 1800s of what we now call the cotton culture. Cotton became king. They began to develop larger and larger plantations. Slavery grew because they needed tons of people to work these plantations. Land itself became worn out with cotton. Cotton is a land killer.
The Civil War disrupted farmland expansion and spelled the end of the plantation era. For the South, hard times would follow.
The war was fought and slavery ended. You begin to find multiple families working on a rural plantation, all trying to survive. So the sharecropping system became the super system all the way up to the Depression. You were not in a region of development. You were now in a region of nothing in the world but survival. Timber became the mainstay of cash funds. With agriculture running full blast and lumbering running full blast, we denuded thousands of acres of forest. And we multiplied very dramatically the influx of settlement into the rivers and streams.
In the Roanoke River watershed alone, over 6,000 square miles of upland forest were cleared. Naked slopes quickly and inevitably yielded to the elements, sending a thick carpet of topsoil down to the clouding river below. There it met with sediments from the Piedmont in upper floodplain. Where is this mud now? Could this be why, more than a century later, the river still runs brown today? Phil Townsend from the University of Wisconsin heads a team studying sediment deposition along the lower Roanoke.
Sediment deposition is what happens to the materials that have been eroded. Where and how much sediment gets deposited is important to creating the topography and creating the ecological system that you have. On the lower part of the Roanoke River floodplain near the Albemarle Sound, we don't see signs of excess sedimentation. The levees are fairly low, they're pretty close to the river water level, and there are broad, flat back swamps. When the river waters rise, they easily flood the back swamps, but they also drain out afterwards. It brings in some sediment, but it's mostly a naturally functioning system. If you go upstream from the lowest parts of the Roanoke River, most of the floodplain doesn't work this way. You see taller levees, broader and wider, with the back swamp separated from the river more, and it's not a situation where the river is functioning the way it normally would. This is where we first got interested in sediments on the Roanoke River floodplain. We were doing field work looking at the forests up on the floodplain above us, and we would come across these steeply incised channels cutting through the floodplain. During high flows, when it's flooding, the water levels are well above the tops of these channels, and that really illustrates how high the water levels come up during flooding events, but it also shows you exactly how much sediment has been deposited here.
On the lowest part of the river near the Sound, the flood of mud hasn't yet piled onto the floodplain. Here, water easily washes back and forth over the low levees. The ready exchange of water between the river and floodplain regularly flushes plant communities. This is a vital function of the system. But just upstream from the mostly unaffected floodplain, where mud is already piled high, the tall levees impede this exchange of water. Channels provide the main pathway to the floodplain for high water. Like a conveyor belt, this sediment-laden flow heaps more and more mud onto the floodplain. As the water and sediments crest the channel banks, they find low-lying pockets on the plain. There, they remain trapped by higher ground as the channel water recedes. This disturbing pattern means normally wet areas are getting even wetter, dry areas drier, and habitat is being lost as intermediate areas disappear. To understand this process better and what it may mean for the Roanoke River, Dr. Townsend's team has come from far and wide to gather data. Their purpose is to create a computer model of the Roanoke system that will depict its past, present, and even its future. What is learned here can help better manage the Roanoke and other brownwater systems like it. The first objective is to map these extraordinary sediment deposits, a task that falls in part to scientists from the U.S. Geological Survey. For them, the work is truly down and dirty. Up on the floodplain itself, where sedimentary layers aren't so exposed, deposition must be measured differently.
To find out how much sediment was deposited on the floodplain, we take cores where we drill holes 20, 30, or even 50 feet deep, and we pull these cores of sediments, or mud really, and look at them, and we can use that as a window into the history of the past 5, 10, or even 20,000 years. Oh, look at that. That is blue. That's just real old back swamp. Pure stuff.
Pure stuff, in this case, means a layer of thoroughly decomposed matter accumulated over hundreds to thousands of years. It tells the team they have drilled beyond the materials they want to measure. At the tops of the cores is organic matter, Dead and still decomposing things piled up over recent decades. Cores from the impacted floodplain show an additional pronounced layer separating the top and bottom materials. This reddish-orange band of clay is soil from upstream. As much as 20 feet thick in some samples, this middle layer points to massive erosion. But when did it first reach the floodplain, and why? To answer those questions indirectly but conclusively, the researchers look for ragweed pollen. Ragweed thrives only in open fields, so its abrupt appearance in a core indicates a period of sudden deforestation. Invariably, the pollen first appears at the start of the red layer, confirming cause and effect. Deforestation triggered the flood of mud. With history as context, there can be no doubt that human activities in the 18th and 19th centuries continue to reshape the Roanoke landscape today. The lower river is muddy, but the reason why is now clear. Precisely how this flood of mud is transforming the river system is also coming into sharper focus, thanks to the researchers' computer model. This dramatic view shows how the river system has changed in the last 300 years as sediment deposition continues to transform the floodplain. But you don't need the fancy tools of an environmental scientist to know something drastic is going on here.
When you climb up these steep banks and look out over the floodplain, you see a system that's completely different from the way it was in the past. The sediments have come and filled in the floodplain and made it flatter and drier. There are fewer different habitat types for the different plant and animal species that use the floodplain. The system has really been simplified.
The last thing you want to do in an ecological system is start to simplify that system. It's like taking spokes out of a wheel. The more spokes you take out of that wheel, if you take too many out, that wheel is going to collapse.
How life is changing in the river itself, a soup of suspended sediments now, isn't as well documented or understood. But local sportsmen can tell you things have changed.
From the time I remember, I'd come down to the river, there was 10 or 15 local fishermen that made a living fishing. They were catching herrings, rock, perch, eel, sturgeon. The river was full of fish. People would come from miles and miles around to buy, to carry home for the salt, to eat fresh, and carry them through the winter. When we started operating the grill, rock, perch, and herrings come right out here out of the Roanoke River. And you cook them in the restaurant. Then something began to happen, and they've got more scathes.
When systems start to simplify, they can become less productive. And from a human perspective, they can become less enjoyable to interact with. When you look at all the people around here that fish and hunt and canoe and birdwatch, there's no doubt that each one of those people hold in their heart a real relationship with this river system. And as it simplifies, a little piece is torn out each time a species is lost.
Hastening ecosystem simplification are the Roanoke's 7 major dams. 3 of these dams are clustered just before the fall line, where the river drops 100 feet from the Piedmont to the bottomland. Operators control the volume and timing of dam releases to meet their twin priorities: protection of human life and property, and power generation. The result is a flood pattern that poorly mimics nature.
Everything in that downstream system is adapted to waters that rise and fall fairly quickly. What the dams do is they take water that would come up and go down quickly, sort of like that, and they turn it into periods of time when the water is out on the floodplain for a long time. And when that happens, the trees are stressed and sometimes even killed. Banks become saturated and fall in the river. All sorts of impacts happen as a result of taking these relatively flashy periods of high water and turning them into extended periods of high water.
One of the ways you'll see that the river and the floodplain are really out of balance is when you look into the forest and the back swamps where the cypress and tupelo create the canopy. When you look underneath those trees, you don't see the seedlings or the young trees coming up. And that's a direct result of the way water flows downstream and how long it impounds behind those levees. That has a real important function in the future when we think about what this system might look like 100 years out.
The flood of mud cannot be turned back. As it makes its way downriver, the mud continues to raise the levees and fill in the back swamps. What precious little remains of the natural functioning lower river system is at grave risk. Without changes to the way we now manage the river, the Roanoke will only become further degraded. We would do well to heed history's warning.
When I travel up and down this river, I'm amazed at the impact that humans can have on our landscape. When you're boating around and you realize that 20 feet of sediment on each side of you is in essence a witness to the history of land clearing upstream. And all that sediment from 8,000 square miles that was cleared came down through the fall line and plunked itself in the river right there. And as the river slowly once again works through that sediment, it's a reminder to all of us how we impact our landscape.
The Roanoke teaches us 3 basic lessons. Although it's possible to manage natural systems, we have to do it carefully and moderately. Because if we don't, it's like trying to control a tiger by hanging onto its tail. You get all sorts of unexpected and undesirable consequences. The second lesson is that these systems do not exist in isolation. They're embedded in a larger world that's significantly changed by people. So we really need to think about how soil moves around and where water comes from, because those impacts affect the Roanoke and every other natural system that we're trying to protect. And the third is that by some amazing good luck, we've arrived at just the right time to make the difference.
If we're going to continue life as we know it, then it's absolutely imperative that we focus on the environment and solve the problems now before they become too bad. We've got to do it now. And yes, indeed, we can make a difference.